So this question was asked in GATE 2016 Electronics and Communication Engineering paper set 2, in which a continuous time filter with transfer function h of s, which is equal to 2s plus 6 upon s square plus 6s plus 8, is converted to a discrete time filter with transfer function g of z, which is given as 2z square minus 0.5032z upon z square minus 0.5032z plus k. Also, you have given the impulse response of this continuous time filter is sampled at 2 Hz, and it is identical at the sampling instance to the impulse response of the discrete time filter. That is, this h of t, that the impulse response of this continuous time filter, is converted to discrete time filter response by sampling the continuous time filter at 2 Hz. So you need to find the value of k. So the NPTEL reference for this question is Principle of Signal and Systems by Professor Aditya Jagannatham, IIT Kanpur. You can find a reference in the lecture, which is Z transform. So the useful data for this question is, if we have given a system and you apply the input as delta of t, then you get y of t as output, and this y of t is defined the impulse response, which is denoted as h of t. So when you apply the input as delta of t, then you get output as impulse response of this system. So this is the first useful data for this question. The second useful data for this question, if you have given a continuous time signal x of t, and you sample this x of t by putting the t equal to nts, where ts is the sampling period, which is given by 1 over fs, and this x of nts denotes your discrete time of x of t. Now the third useful data for this question is, if we have given a signal a to the power u of n in discrete time domain, then the z transform of this signal is given by z over z minus a. So these three are the useful data for this question. Now coming to the solution, in this question you have given h of s as 2s plus 6 upon s square plus 6s plus 8. So you can find h of t from this h of s by applying the inverse Laplace transform to this h of s. So your h of s is given as 2s plus 6 upon s square plus 6s plus 8. You can write this h of s as 2s plus 6 upon s square plus 4s plus 2s plus 8. Also you can write this as 2s plus 6 upon s plus 4 into s plus 2. So your h of s is given as 2s plus 6 upon s plus 4 into s plus 2. So by applying the partial fraction, you get a over s plus 4 plus b over s plus 2. Or you can write this one as 2s plus 6 upon s plus 4 into s plus 2 is equal to a into s plus 2 plus b into s plus 4 upon s plus 4 into s plus 2. So denominator of RHS and LHS will be cancelled out, and you get a into s plus 2 plus b into s plus 4 is equal to 2s plus 6. So when you put s equal to minus 2, you get b equal to 1, and when you put s equal to minus 4, you get a equal to 1. Now your h of s by the help of partial fraction can be written as 1 over s plus 2 plus 1 over s plus 4. Now by applying the inverse Laplace transform, you get h of t as e to the power minus 2t u of t plus e to the power minus 4t u of t. I am using the Laplace transform of e to the power minus at ut is given as 1 over s plus a. So by the help of this Laplace transform relationship, I am converting this h of s to h of t. Now, your h of t is sampled at 2 Hertz. So you are applying the sampling to h of t to obtain the h of n. So your t changed to nts, or you can write this nts as n into 1 over fs. Fs you have given as 2 Hertz. So this becomes n by 2. So when you put t equal to n by 2, you get h of n equal to e to the power minus 2 into n by 2 u of n plus e to the power minus 4 into n by 2 u of n, which is equal to e to the power minus n u of n plus e to the power minus 2n u of n. Now, to find the jet transform of this h of n, I will use the jet transform of a to the power n u of n. So the jet transform of this a to the power n u of n is given as z over z minus a. Now you have given h of n, which is equal to e to the power minus n u of n plus e to the power minus 2n u of n. And you know jet transform of this a of n u of n is given as z over z minus a. So when you put a equal to e to the power minus 1, then you get e to the power minus n u of n, and the jet transform is given as z over z minus e to the power minus 1. Similarly, when you put a equal to e to the power minus 2, then you get jet transform of e to the power minus 2n u of n as z over z minus e to the power minus 2. So your h of z, the jet transform of this h of n, becomes h of z, which is equal to z over z minus e to the power minus 1 plus z over z minus e to the power minus 2. Or you can write this one as z into z minus e to the power minus 2 plus z minus e to the power minus 1 into z upon z minus e to the power minus 1 into z minus e to the power minus 2. By putting E inverse as 0.3678 and e to the power minus 2 as 0.1353 and e to the power minus 3 is equal to 0.049, you get h of z is equal to 2z square minus 0.5032z upon z square minus 0.5032z plus 0.049. So by comparing g of z, which is given in the question as 2z square minus 0.5032z upon z square minus 0.5032z plus k, you get the value of k is 0.049. So the correct answer for this question is k is 0.049.